Section 1.7, Distance and Midpoint Formulas in Circles. Using the distance formula, we have used the Pythagorean theorem to find the lengths of the sides of a right triangle. Here we will use this theorem again to find the distances on the rectangular coordinate system. By finding distance on the rectangular coordinate system, we can make a connection between the geometry of a conic and algebra, which opens up a world of opportunities for application. Our first step is to develop a formula to find the distances between points on the rectangular coordinate system. We will plot the points and create a right triangle, much as we did when we found slope in graphs and functions. When we take it one step further and use the Pythagorean theorem to find the length of the hypotenuse of the triangle, which is the distance between the points. Let's take a look at example number 1. We're going to use the rectangular coordinate system to find the distance between the points 6, 4, and 2, 1. So here we have our rectangular coordinate system. We want to be able to graph the first point, which is 2, 1. So starting from 0, we move to the right 2 points and then up 1 to get the first point of 2, 1. The next point we have 6, 4. So we're going to move to your right the coordinate of 6 points and then up 4. So this is considered the rise, this is considered the run, and therefore this is the value of D. This is the hypotenuse. So what we notice here is that if we come from this point to this point, if you go up 1, 2, 3 segments, that means you have 3 for the rise. If you start over here and then move over to this point, you're going to move over 1, 2, 3, 4, and therefore 4 is going to represent the run. So now that we have those 2 points, we can figure out what is the distance between those 2 points. So what we're going to do is we're going to use the Pythagorean theorem to find D and the distance between the 2 points. Now the Pythagorean theorem states that we have a squared plus b squared equals c squared. But since we're using D, we're not going to use c. In this case, we're using D. And then we're going to substitute in the values. So we have 3 for the value of a, 4 for the value of b. And what we're going to do is we're going to square those and then add them, set it to equal d squared. Well, 3 squared is 9, 4 squared is 16. When we add 9 plus 16, we get 25. Then we need to ask ourselves, using the square root property, what do we have to square to get 25? Well, there are 2 numbers that we can square to get 25. One of them is positive 5, one of them is negative 5. When we talk about distance, we do not include negative values, so we're going to cross out the negative value, and we can say that the distance is equal to 5. So the distance between the 2 points, 6, 4, and 2, 1, is 5.